You are interested in the wonderful world that is derivatives. Hello, I'm your teacher William Hussey for this virtual lesson on what a derivative is and the rules behind it. The first thing that I bet is on your mind is, what is a derivative? Well, a derivative is basically just the instantaneous rate of change of an equation, or in layman's term I guess, the slope at a point. The derivative is noted by an apostrophe, which is pronounced as prime. To find one of these derivatives, you have to multiply the coefficient of a variable by that variable's power, and then knock that sucker variable's power down by 1. So this 3x squared here, that becomes 6x, because you're multiplying that 3 by that 2. But then you're probably wondering, well, what if there is no variable? What if you just have a single 1? Well, that derivative is 0, so in the case of 3x squared plus 1, the derivative would still just be 6x. Derivatives start to get a little bit more complicated once we introduce the product rule here. The product rule is used when you're given an equation where you have to find the derivative of something like 3x squared times 6x, because these two numbers have to be multiplied together first. You can't just find the derivative of both terms like you would with that 3x squared plus 1. To complete the product rule, you first have to multiply the first term by the derivative of the second term, and then add it to the derivative of the first term multiplied by the second term. A way to make it sound a little bit nicer is uv prime plus vu prime. So 3x squared here is going to be our u, and 6x is going to be our v, making 6x our u prime and 6 our v prime. We do a little bit of uv prime plus vu prime here, and we end up with a final answer of 54x squared. So what happens when the function is in fractional form and you have a polynomial fraction? Here we introduce something called the quotient rule, which is very commonly known as low d high times high d low all over low squared. The term on top, or the numerator, is going to be your u, and the term on the bottom is going to be the v. And you're going to have vu prime minus uv prime all over v squared. Let's say you're given a situation in which you have 3x squared over x. So the u in this situation is going to be the numerator, or 3x squared, and the v is going to be the denominator, which is x. U prime is going to turn into 6x, and v prime is going to be 1. And when you do low d high times high d low all over low squared, you're eventually going to get 6x squared minus 3x squared all over x squared, which will just simplify out to a nice even 3. The worst rule when it comes to probably all of calculus, but especially derivatives, is called the chain rule. The chain rule is when you have a polynomial that is raised to an exponent. To solve these, you're going to have to take the derivative of the outside times the inside times the derivative of the inside. So for here, the derivative of the outside would just be 2 times the inside, which would be 3x squared minus 6. And then that's going to be multiplied by the derivative of the inside, which is just 6x. This is going to be simplified out to 12x times 3x squared minus 6, which is going to equal out to 36x cubed minus 72x. By this point, you're probably thinking, I've got to be done, right? I mean, I've gone through very, very hard topics. Not quite. You see, after we've learned these, we now get to put them together with product with a chain rule. We got the product with a quotient rule, and we've got a chain with a quotient rule. These are all torturous, but now that you know how to do one, you should be able to learn how to do both. Honestly, derivatives aren't that bad in general. I mean, you just got the entire gist of it. I mean, that's it right there.